Hey guys, it's me, Miss Yealy. I'm here with Miss Adams.
Hey guys.
We are looking at 11.02 notes. Hopefully at this point in our online learning process, you've completed all the assignments, 10.01 assignment, the 11.01 notes in practice, and now we are on week 3 in 11.02 notes. So hopefully you're watching this video looking at the notes from either the content library, or not content library, the OneNote, or Microsoft Teams, or on the website, and you have a copy of those notes in front of you. We are going to be graphing log functions, and I guess here we go. The first thing we're going to talk about is a log function is the inverse of an exponential function. An inverse of an exponential function. We've actually seen inverses a couple times throughout the year, but an inverse means that we're going to take the x and the y values and switch them. So to find an inverse, you are switching your x and your y values. Out of lead. Sorry. Okay, you're going to switch your x and y values. In order to look at this from exponential form into log form, we start with y equals b to the x power, which is our exponential form. Is our exponential form. If I switch the x and the y, I would get x equals b to the y power. And in order to solve for y, to get y by itself, I need to rewrite this in log form. So I would have log base b of x equals y, because the log always equals the exponent. In this case, the exponent is y. So this is how we go from exponential form to log form. Oh, sorry, form, F-O-R-M. So we go from exponential form into log form. And before we actually get into graphing logs with our shape, our asymptote, and our point, I'm going to kind of give you a general background of how an exponential function and a log function look when we graph them on the same plane. When we graph, we have the same transformations. Our A, H, and our K are back, and they're the same as they always have been. But we're, again, just giving you an overview of what these two graphs look like before we get into just graphing logs by themselves. So normally you wouldn't create this table, but you could always do that if that's how you wanted to solve it. To start, I'm going to graph the graph y equals 3 to the x power. I'm going to start with y equals 3 to the 0 power, because anytime you raise an exponent to the 0 power, you're always going to get 1. So 0, comma 1 is the first point on our graph. So over 0, up 1, we have the first point on our graph. If I plug in 1, 3 to the first power is 3. So the point 1, 3 over 1 up 3 is also on the graph. And then if I plug in 2, 3 squared is 9. So over 2, up 9. 1, 2, 3. You can always do this to our negative exponents as well. When I raise 3 to a -1, negative exponents flip to the bottom, which creates a 1/3. And this is not how we're going to, or the process we're going to use to graph these each time, but I just want to show you what these graphs look like when we do the log versus the exponential form. So, and then 3 to the -2 is 1/9. And if you remember from our exponential functions, when we graphed them, our asymptote is y equals k. And our k value, in this case, is 0. So our k value is 0. So our asymptote is y equals 0. Because when we raise 3 to any power, we're never going to get a negative answer. So our y equals 0 is the asymptote for this. And And we can draw our graph. This is growth, so growth starts close and it grows far away. And then the domain for that graph is from negative infinity to positive infinity. And the range would be from 0 up to infinity. From 0 up to infinity. So that is what an exponential function looks like. A little bit different, just plugging in points, but I wanted to use this to compare to a log function. When I do a log function, we will be switching x and y. The easiest argument when I solve or when I find a point for a log function is to plug in 1 for the argument. If I plug in 1 for that argument, I get log base 3 of 1. And I have to think, what exponent turns that 3 into a 1? What exponent turns a base into a 1? The only exponent that does that is 0. Anytime the argument equals 1, the answer is always 0 because the exponent of 0 makes the argument 1. So the point 1, 0 is on our log function. And that is a very important point when we're graphing logs. There's Lady saying hello. So this point is a very important point when we're graphing logs, and we're actually going to use this idea when we get into graphing each individual log. So the big thing is when you have log of any base, if the argument is 1, it's always going to create a 0. Whenever the argument is 1, we're always going to get a 0 for our answer. And that will be our key point when we graph the logs. Another point that we can plug in is 3. If I plug in a 3, log base 3 of 3, what exponent turns a 3 into a 3? That is an exponent of 1. So 3 comma 1 is also a point on our graph. And then I can also plug in 9. Log base 3 of 9 is 2. The exponent that turns 3 into a 9 is a 2. So 9 is up at 2. And then we can plug in 1/3. Get log base 3 of 1/3. What type of exponents turn things into fraction? That is a negative exponent. So if I 1/3 down -1, and then 1/9. And if you are comparing these two graphs, you might notice that these points are the same. The x and the y values are just switching, and that goes back to the idea of inverses where you switch your x and your y. So when you have inverse functions, the x and the y values essentially switch. So we go from whatever was the x becomes the y, and whatever was the y becomes the x. Log functions are not going to have a horizontal asymptote. They are going to have a vertical asymptote. In this case, the idea with logs is that the answer or the y value can never be negative. So the asymptote in this case is going to be x equals 0. So I can't put an argument in that is a negative answer or a negative, because when I raise things to a power, I'm never going to get a negative. So, it's like when we're solving logs, when we were checking for solving, the argument always had to be greater than 0. So in this case, the asymptote is x equals 0. That is what our log function looks like. So when you have inverse equations and you put them on the same graph, it is actually a reflection across the line y equals x. So it's like I've taken this curve and reflected it across the imaginary line. All right, and then the domain for this graph, now the domain cannot go from negative infinity to positive infinity. This domain has to start at our vertical asymptote at 0 and go to infinity. But our range can go from negative infinity up to infinity. This is increasing, it's just increasing slowly. So our range goes from negative infinity to positive infinity. If you look what do you notice about these characteristics? If you look at your asymptote, we had y equals 0, and now we have x equals 0. And our domain was negative infinity to positive infinity, but here our range is negative infinity to positive infinity. And then the range for our exponential goes from 0 to infinity, and this one goes from 0 to infinity for the domain. So what's happening is everything is switching. So essentially, my range became my domain became my range, and this has to do with the x and the y values switching. If the x and the y values switch, domain has to do with our x values, it's going to switch and become my y values, and range is our y values, and that becomes our x values. So everything is their opposite, everything is switching from x and y's. And just so you guys know, this is a little bit different than the process we're actually going to be using to graph these logs. So essentially, when I'm picking out my x and my y values, especially for my logs, I was picking these based off of what values are going to work and make sense. You have to pick specific x values in order for them to work out to be nice, pretty whole numbers. And I'm just looking at the powers of 3. So that's where I got the 1, 3, 9, and the 1/3 and the 1/9. So please don't stress too much about this process, because it's going to be a little bit different when we get into the actual process of graphing the logs. When we graph logs, we're going to have 3 pieces of information. We're going to have our shape, our vertical asymptote, and our point. So when we had graphed exponents, we had 4 different shapes. When we graph logs, there's only going to be 2 shapes. There's going to be with no reflection and with a reflection. Our vertical asymptote is always going to be on the left side, because when we solve, the argument has to be greater than 0. The argument has to be a positive number. So the vertical asymptote is going to be on the left side. If there's no reflection, it goes from low to high. If there is a reflection, it's doing the opposite. It's going from high to low. And then it's still with a reflection, the vertical asymptote is on the left side of the graph. Your vertical asymptote, x equals h, is our vertical asymptote. So that's coming from our h value. And it's x equals instead of y equals. So you're setting your argument equal to 0. Setting the argument equal to 0. It is just going to be your your h value. For the point, we want to go off of the idea that we're setting the argument equal to 1, because if you remember, I just said before, if we have any base and the argument is 1, that's always going to be a 0, because anytime you raise a base, or what exponent turns any base into a 1 is a 0. And then the y value is just going to be your k. So our point is going to be whatever makes the argument equal to 1, and our y value is always the k value. So let's practice. I know this is kind of a lot to get into, but I don't think it's as hard as it seems when you actually start practicing the problems. So let's look at number 1. On number 1, our a value is in front of the log. The a value in this case, there is no number in front of the log that we can see, so it is assumed to be a 1. our h value inside the parentheses, there is no value inside the parentheses, so our h value is 0. And our k value outside of the parentheses is also a 0. Our base is 2, and the base really doesn't have much to do with the problem. We just have you list it. So this graph is positive because our a value is positive. So this is based on your a value, essentially because a is positive. And that's going to help us draw the shape. When I look at my vertical asymptote is x equals 0 because it's my h value. So the vertical asymptote comes from your h value. In this case, 0. For the point, we're going to take our argument. In this case, the argument is x. So I take that x and I set it equal to 1. So that is going to be a 1. And my y value is the k value. In this case, 0. So my point is 0, 1. 1, 0. It should always be to the left, right of the asymptote. So the point should always be to the right of the asymptote. Because when you make a log, the argument has to be a positive number. You can't get a negative answer. And then I can draw the shape. Because this is positive, because our a value was positive, I'm going to go from low to high to graph this. If the a value is negative, you go from high to low. So positive, you go from low to high. The domain is restricted in this case because of our vertical asymptote. We're going from 0 to infinity, and our range goes from -infinity to infinity. If I'm walking on this curve, I would be going up. So this is increasing. And then for transformations, that's based on my a, my h, and my k. A is 1, that does not stretch or compress. H does not shift left or right, and K does not shift up or down. So in this case, there are no transformations. All right, so that is one of our graphs. Let's go on to the next page and do a few more together. So for number 2, my a value is -3 this time. So that gives me a reflection and a stretch by 3. My h is inside the parentheses as 0. And then my k is up at 2, up 2. My vertical asymptote is going to come from y equals your h value, x equals your h value. X equals 0 is my vertical asymptote. It is always x equals, even though I keep saying y. So x equals 0 is my asymptote. And it's going to be at 0 unless you shift to the left or right. The asymptote always starts at 0 unless there is a transformation shifting either to the left or to the right. The next thing we're going to do is we're going to find our point. To find the point, we're going to set the argument equal to 1. So setting my argument, just so you guys know, the argument is the part in parentheses. So if I have log base b, this part in parentheses is the argument. So if I'm referencing the argument and you're like, what is an argument? It's the part in parentheses. So for my x value, I always take the argument and set it equal to 1. And again, I haven't changed the argument. I haven't put an h or shifting it left or right. So it's going to be 1 again for this problem. So my x value is 1. My y value is the k value, in this case 2. So over 1 up 2 is my point. So I've got my asymptote, I've got my point, and now I need to draw my shape. And the shape is based on your positive or negative. This graph is negative because the a value is negative. It is a reflection. So this will go from high to low. Essentially, it ends going down. So that's the reflection. From high to low. My point was 1, 2. Domain goes from left to right, so that asymptote is in the way. So this goes from 0 to infinity. The range goes from negative infinity up to infinity. And this graph is decreasing. This graph is decreasing. If you notice, I left the base blank. That was unintentional, but the base is 2, and I didn't actually use the base at all to do the problem. So the base doesn't really have an impact on what we're doing to solve this or to graph the function, because we're only worried about making the argument 1. And the reason that this point works out this way is if I plug a 1 in for the argument, 3 log base 2 of 1 plus 2. If we had you actually solve this out, you would want to solve this log first. What exponent turns this base 2 into a 1 would be a 0 times 3 plus 2. 3 times 0 is 3. No, it's not. It's 0. 3 times 0 is 0 plus 2. No matter what you make, or what the a value is, it's always going to just equal the k because we're turning the argument into 1. If the argument is a 1, then this always becomes a 0 here. So we're not asking you to show this work because it's always going to end up being the k value. It always ends up being that k value because we're turning the argument into a 1. But that's why we're doing that. All right, let's do number 3. And maybe you want to stop and try it and do it by yourself. Maybe not, that's cool too. At least you're watching the video. A is 1. H is the opposite. So H is now going to be positive 3. So I'm changing the sign. And K is 0. So for my transformations, if A is 1, that doesn't stretch or compress the graph. H is 3, that shifts the graph right 3. And K does not, K being 0 doesn't have any transformations either. So for my vertical asymptote, let's see if I can get it right this time. Vertical asymptote is x equals the H value, which is 3. So x equals 3 here. I'm going to go over to 3 and draw that on my graph, which makes sense that we're shifting that asymptote from 0, now shifting to the right 3. So shifts to the right 3. When I do my point, I want to turn the argument into a 1. So I take that x minus 3, and I want to set that equal to a 1. Adding 3 to both sides, x equals 4. So I want to take my argument, this is my argument, and I want to set that equal to a 1. Because if I make that argument 1, and I'm actually going to show the work, log base 2, turning that into a 1, what exponent turns 2 into a 1 would be a 0, which does match my k value. So my point is 4, 0. The point should always be on the right side of your asymptote. You should never have any points to the left of the asymptote. This graph, A is positive. So we're going from low to high. Essentially, anytime you're positive, you want to end going up from low to high. If it was negative, you're ending going down. And I know it's positive because my A value is positive. Domain goes from 3 to infinity based on my vertical asymptote of 3. And then the range goes from negative infinity to infinity. And this graph, if I'm walking on this curve going from left to right, is increasing. And the base is 2. Didn't really need it to solve the problem because I made the argument 1, but it is 2 for the problem. I think I got everything. All right, and last but not least, number 4. Number 4, the A value is 1. My B value is 3. I won't forget it this time. My H value is the opposite of positive 2, so it's negative 2. And my K value is negative 3. For my transformations, it's not going to be a stretch or compression. My H shifts it to the left 2. My K shifts it down 3. And I can find my vertical asymptote by setting my, using my H, x equals negative 2, which from 0 shifts it left 2. Makes sense, right? All right, and then I'm going to find my point. In order to find my point, I'm going to take my argument and set it equal to 1. So I'm going to take my argument and set it equal to 1. X plus 2 equals 1. Subtract 2, subtract 2. X equals negative 1. And then the y value, it is going to be the k, but I'll show you why. Log base 3 of negative 1 plus 2, ooh, running out of space, minus 3. In the parentheses, negative 1 plus 2 is 1. What exponent turns a 3 into a 1? The exponent that turns 3 into 1 is 0. 0 minus 3 is negative 3, which just is the k value, and it will be the k value every time. So negative 1, negative 3 is my point. When I draw this curve, I'm looking at my A value. This is positive. Positive goes from low to high. From low to high. My point was negative 1, negative 3. My domain is from the asymptote, negative 2 to infinity. And my range, negative infinity to infinity. And this graph is increasing because I'm going up. If you guys are confused or lost, what I would recommend that you do is go back to this section on the front that tells you what to do for each part of this. So what does the shape look like, and how do you know, essentially, is it reflected or not reflected based on the A value? Your vertical asymptote is always x equals h, and this is how you find your point. So just use that if you guys are lost. If you have any questions, obviously let us know via Remind or Microsoft Teams, or tune in to our live chat happening on Tuesday. I think it's the 31st. So hopefully you guys are keeping up. Thanks for watching the video. And if you have questions, let us know.